Hello everybody and welcome back to Kerbal Space Program, where last episode I made a few mistakes, shall we say. Luckily, it didn't end up too bad. This thing, I was a little bit aggressive with the gravity turn on our test flight on it, and it's pretty top heavy, so I need to be a little more cautious about that. But we can go ahead and launch this as is right now, and it'll be fine. I did want to maybe add a little bit more fuel into this center core. I mean, I don't think it's strictly necessary. No, I don't think it's necessary. So we'll just save this and launch it. This thing is going into solar orbit, but we'll hopefully, while doing that, run a few more contracts. Send up a few more launches. God, this looks ridiculous. Luckily, this part is not physics enabled. So, yeah, this is a thing that we're doing, I guess. Off we go. Our thrust to weight is plenty high for this. There's no doubt about that. We also added a couple of extra fins on here to help out with some of those issues. But I'm going to wait until our apoapsis is a little bit higher before starting any sort of horizontal velocity, so I'm taking this a little bit more cautiously. Okay, 5 kilometers. We're going to get ourselves a little bit of horizontal speed now. Okay, we're passing through max Q currently. We're going to hold right here and pitch a little further. Okay. That's that same issue that we had previously. We're getting a lot of horizontal speed right now. We need some vertical speed. We need a lot of vertical speed. Whoa. Okay. This thing is really exciting. I think... Is our center of mass an issue? Okay. We are simply going to abort this particular flight. We're going to try to turn over towards surface retrograde if we can. We're going to try to rescue as much as we can. This is not a simulated flight, but we clearly have some issues, and I think it's the mass on this survey scanner that's causing this to happen, is my theory. Can we get over to retrograde? That appears to be a negative. Aerodynamic forces are holding us here. Okay, so this is just a loss. It would appear. Unless we can hold retrograde with gimbaling? No. No. We definitely can't. Okay, so this thing is just a loss then. That's fine. We need to check our center of mass. I think this is throwing our center of mass off and causing that extreme pitch towards 90 degrees, which while we're still in the atmosphere is causing us to have that slight issue of tumbling. I like how we're actually decelerating dramatically. We do not survive this impact. Okay. We're not reverting that. So I want to investigate what's going on there. I think it's the survey scanner. So, let's check. Center of mass. I mean... I'm not sure it is. I think it's just that this thing is so top-heavy. Like, we need to lower our center of mass. We can do that a couple of different ways. We can put more fuel down here. We can just make it less aggressive with the gravity turn. Like, we could, in theory, put another T-800 right here. Now, this would absolutely not have thrust to weight in this phase. However, did we grab vectors? We could use a vector. It'd be ridiculous. What if we did this? Bicouple that. I mean, our thrust to weight is okay. So that lowers our center of mass a little bit, but I'm going to drastically change our ascent profile, and this is not going to be an efficient ascent profile, okay? We're going to go very high, and then we're going to go sideways. The old-fashioned way. So off we go with additional fuel. I like how parts are still falling from that previous flight, and we're already launching the next one. Pretty glorious. So we're just going pure vertical until we hit an apoapsis of at least 80 kilometers. Hopefully we're not going to be going too slowly. Also, I need to adjust this fairing to be here. There we go. Don't want to stage the fairing too early. This is definitely a low thrust to weight ratio. I'm a little concerned about our vertical speed. That said, we are passing through max Q now. Our speed is getting up there. It'll continue to go up. Thrust to weight is already positive on this stage, which is a good sign. But this is definitely not an efficient ascent profile. But I want all of the power of these side boosters straight up. We're still not very high. Our thrust to weight is a little on the low side. We may have to upgrade these to bigger tanks, or at least the center core. Yeah, I think future launches we should upgrade the center core. But this'll do for now. So our apoapsis is currently 55. We can upgrade this to big orange tank with a mainsail and then have perhaps SRBs, like SLS style. That could work. Apoapsis is currently in space. Time to apoapsis is going up, so that is really good to see. We're going to begin our gravity turn now. Call it a gravity turn. This is not a gravity turn. We're just going to turn towards the horizon. And yeah, at this altitude, it's perfectly safe to do this. We're going to deploy our fairing for additional thrust to weight. Time to apoapsis is currently decreasing, but that's okay. We should have enough time to get orbital velocity, in theory. But we definitely need to upgrade this center core for this. So let's get that sweet, sweet horizontal speed. What's our thrust to weight over here? 1.8. Yeah, that should be sufficient. We're going to need to start pushing up our time to apoapsis, and this is going to be quite a high apoapsis because of this ascent profile. that is well known. I'm not surprised by this in the slightest. Time to apoapsis has started going up. That is perfect. Once it reaches 100 kilometers, that is when we'll do our maneuver node. $99 kilometers and 100. Okay, so we'll do a maneuver node right here, and we'll just push that out about like so. There we go. This is a burn time of 13 seconds. We should also extend our Gigantors. There we go. Rotate over to the maneuver node. And we want to burn this at T minus 7.5 seconds. Whoa, 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 whoa. I meant to physics warp. That's physics warp. Excellent. 7.5 seconds is when we want to perform this burn. So right about then. So I mean, we got it into orbit, but it definitely needs some upgrades. Okay, good enough. We've got 436 meters per second left. Of course, our target orbit is around the sun, and this is our target orbit here. This is pretty equatorial, but the first thing that we need to do is we need to escape Kerbal. Now, I want to just focus on Kerbal if we can. Apparently we can't. There we go. Excellent. So, at this point, we probably want to do like a moon slingshot if we can manage that. We can get a moon interception from probably somewhere around here. And what's that looking like? Yeah. That's looking good. We can do a quick adjustment of this. Go a little bit faster or slower. This is going to give us that's a second moon encounter, technically. We want an escape. So a slingshot that looks something kind of like that would do. Now this is going to be a very, very long burn because we are utilizing this Dawn electric propulsion system, which has a very, very low thrust to weight, but extreme efficiency. So I'm not going to force you guys to sit through all of that burning, but for right now, we want to get over to the maneuver node, and we will physics warp that turn. Most of this burn is going to happen like this, but this is an 11-minute, 56-second burn. Like, this is ultra efficient, and also ultra not useful, at least if we're in any sort of a rush. So I'm going to warp towards that maneuver. Let's see here. We are over here. We need to warp to next maneuver. There we go. Fantastic. And we will begin this burn momentarily. In fact, we needed to begin this burn faster than this. I'm reasonably certain about that, because we're burning out this entire core here. There we go. Activate that. And you can see, this is a very, very inefficient thing. So we can physics warp for a little bit as we attempt to sit on the maneuver node, but apparently the SAS doesn't like that. So this is fine. Let's take a quick look at what our current orbit is. Nowhere near what we need it to be. Okay. So yeah, this is largely fine. This is going to take a lot. Let's actually deploy the survey scanner right now. And let's perform an orbital... Oh, we need to be in a stable polar orbit between 60 and 1,500 kilometers. I did not realize we had to be in a polar orbit. That's okay. I was hoping to do a flyby survey scan of Kerbal and the moon on the way, but it would appear that that's not going to happen. So, this one time, we are going to be doing this. I'm going to try to physics warp through this to make it go a little faster, only a 2.5 minute burn instead of a 10-minute burn. The SAS is having a bit of a hard time actually being on the maneuver node. Let's try to push that a little towards prograde here. I'm actually just going to go on stability assist. Okay. So after this, we're not going to be showing any of these unless I absolutely have to, but I want everyone to know my pain. These are mega efficient. They're mega bad if you're in any sort of a hurry. I do want to be on the maneuver node. That would be ideal. Unfortunately, physics warp can have some interesting effects on that. Okay, so we are currently here. Our apoapsis will be getting pushed out further and further and further. But basically the flight of this satellite, from here on out, I'm probably going to be doing mostly off-camera. I'll do the warping and the actual burning off-camera, but we'll set up maneuver nodes for it that I will follow, mostly, knowing me. I'll probably not entirely follow them. Okay, so this burn is getting very close to done. By very close, I mean we've only got a little over a minute left. So that's nice. And realistically, these comsats, this is basically the final version of our comsat. And we'll get them inserted into orbits and things like that, but mostly when we're doing these ion burns, this will be off camera. And we'll be shifting over to something else rather soon. I want to get the solar gateway built, and we need to decide where we want it to go. Do we want it to go external or internal, essentially? Do we want it to be in here, or do we want it to be out here? And I'm leaning towards having the solar gateway be like halfway between Kerbal and Duna. I think that'll be an interesting place to put it. Our apoapsis is very slowly increasing. Okay. Being pointed at the maneuver node was not increasing the maneuver node. It's kind of weird. I guess we'll get rid of that maneuver node and just burn prograde for right now. There we go. We've got ourselves a moon encounter. What's our moon periapsis looking like here? 50 kilometers, and that's an escape. That'll do. So we will leave the time warp, or rather the physics warp, and this guy is on its way. So once it gets out here, we are, of course, in orbit of the sun. And we need to get ourselves into this orbit here, which our inclination is pretty close to. But we will need to lower our periapsis dramatically and raise our apoapsis dramatically. So somewhere around here, we would do a prograde burn. Maybe not exactly there. Actually, that was some radial. We do not want radial. No, that's still radial. At this angle, it's really hard to do this. There we go. That'll do. And then we'll bring our apoapsis back a little bit. Yeah, like that. And then we'll need to lower our periapsis down to here. I wonder if this thing is going to have overheating issues. I didn't think about that, but this is in between Eve and Moho. Well, our contract will be completed by the time it burns up, if it's going to burn up. So that's the thing. This guy is on its way now. We have 166 days before it gets to its node. So let's head on back to the Space Center and start thinking about what we want to do next. And I want to put up the first segment of our solar gateway. So let's see here. In terms of our active contracts, new orbital station on a solar orbit. This guy right here. We need a facility supporting at least 5 Kerbals and 2 pilots on the station. Okay. So, first things first, we're going to need to construct the station component. We're going to create a new one here, and we are going to use the cupola module. Perfect. Now, this can seat how many? Is that only 1? Yeah, that's a crew capacity of 1. So we need 4 more crew capacity to fit into this thing. This thing can fit 4. So there we go. There's our 5 right there. And we're going to call this the Solar Gateway. There we go. We'll save that. This thing is not coming back. So we do definitely want in our kind of central core here, we do want a mobile processing lab. So we'll put something like that. And this is kind of the core of our gateway here. We can do an inflatable airlock. What exactly does that? That's a docking node. When trying to dock in that last small distance is just too far, this adapter with patented extendomatic subsystems for extra portability will fill the gap, not to be used as an accordion. So if we place this here, and we opened the airlock, I like it. This is probably going to be our standard docking port, but we'll need to figure out where exactly on this we want it. For right now, we're going to need some power flow, for sure. We're probably going to want some batteries on this thing as well. I'll put a single battery pack. That's kind of blocking the view, isn't it? Perhaps we should have a payload bay. So like a service bay here. And then inside of that service bay, we would put in a few things like batteries. So a couple of Z400s, redundant, over here, and over here. There we go. We'll bring a few science experiments with us, in particular the negative gravioli detector, mystery goo containment unit. A seismic accelerometer isn't going to be super useful, but we can have a barometer in here, as well as a thermometer. There we go. And I suppose we could have a telescope on this thing. I've never really used one of these. We might want to have this on a separate module, not on our central core, because we're going to have to we're going to have to bring several modules into this to make it properly work, right? So that's fine. We can bring a fluid spectrovariometer. Not that that's actually going to do anything. This has to be in an atmosphere. And this thing is never going into an atmosphere. Okay, and then I would like to have a Science Junior on here, but I think we will avoid that just for size purposes. So this thing is going to need a bit of a way to get around and maneuver. We'll also need a little bit of central fuel storage for when we dock things to this. Now, I do want to have a single Jumbo 64 tank. This is going to be our main fuel storage in this central core. We will probably have additional fuel modules on this. And then it will also need to have some form of engines, and we're going to use poodles. Or just the single poodle, like that. So that would be what we're delivering to solar orbit. That's a lot of mass. We're going to need a super ultra heavy lift rocket to lift this. And we're not done yet either. We need to have some form of power generation on this. And I think we'll put the solar panels there. Okay. And of course, we will need some way to dock other vehicles to this. Like the inflatable airlock. And I don't want this to be in line with our solar panels. So I think what we're going to do is we're just going to put a single set of docking ports here and here for now. And if we want to dock more modules to this, we'll have to put in a docking module. But for now, this will work. Do these allow crossfeed? They do. Great. Okay, so that should do. Now, if we want to have something docked to that, what would work for that? The inflatable airlock, could we perhaps just have a simple clampatron? Just connecting in like this? I'm not sure. We may have to run some experiments on that. But this is... How much mass is this that we're delivering to solar orbit? This is almost 50 tons that we're delivering to solar orbit. That is a lot. That's a whole lot. So we're definitely going to need a big, big lifter for this thing. Like, this is going to be huge. However, it is time to put a cut in here, so I'm going to go ahead and do that. And next episode, we'll run some experiments on this inflatable airlock and see how docking with that works up, or docking up with that works, and we will build a super heavy lifter to put the solar gateway in solar orbit. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.